Hello and welcome to podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, or TuneIn Radio, or you can add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, and please give us feedback. You can leave a review on iTunes, send us a tweet, send us an email, or leave a message on Google+. You can also leave a comment in our show notes. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. I would also like to thank Hired, a job marketplace for developers, for sponsoring this episode of podcast.init. Use the link hired.com/podcastinit to double your signing bonus. We are recording today on October 2nd, 2015, and your hosts as usual are Tobias, Macey, and Patti. Today we are interviewing Dag Brattli about the RxPy project. Dag, could you please introduce yourself?
Yeah, hello. My name is Dag Brattli. I work for Microsoft in Norway, 69 degrees north, so it's probably the most northern Microsoft office in the world. So I work for the Outlook and Office 365 team. For Fast, it's called. It's a company that was actually bought by Microsoft some years ago. Work within the search and analytics team.
That's great. So how did you get introduced to Python?
Python it's sort of hard to remember. I'm not that young anymore, so I remember at the university, and it's the first version of Python I can remember is 1.5. So we are going back to 97, I think. And I've been using Python all since then, but I'm not using it in at the office anymore. Use C# and other things. So Python is only something I use in the weekends as a spare time hobby.
So for our listeners who haven't heard of it before, can you describe what RxPy is and why someone might want to use it?
Yeah, RxPy is a library for event processing. So it's something you can use to process event streams. So you can, so if you have some programs that handle different kinds of event streams, and you need to react on what's happening in those event streams, maybe you want to do some filtering or combine the events in some way, then RxPy should be a good choice.
And what problem domains are best suited for using the ReactiveX approach?
I think that if you have some backend services that needs to deal with multiple async data streams, then it's best suited for RxPy. If you have some streams of flight information, weather information, location data, stock information, and you need to do something with those data that you want to filter it or transform the values in any way. If you want to do some aggregation, some sums, and some running totals, averages, if you want to combine the data streams in any way, or if you need to do some time shifting, as we call it, that if you want to throttle the data streams, delay the data streams in any way, then it's a good choice for RxPy.
And what is involved in integrating RxPy into an existing code base?
Integrating should be quite easy. It's a bit different if your application is threaded or if it's using some kind of event loop. So if it's threaded, then you can just sort of go ahead and use it. But if you have some event loop, you need to integrate with what we call a scheduler. And RxPy has scheduler for all the common event loops used in Python, like async IO, gevent, twisted, tk, qt, pygame, and the IO loop. So we have examples on the GitHub site where you can see some how you can do this.
And talking about documentation, what are some resources or tutorials that you recommend to people when they're trying to understand how and when to use the ReactiveX tools and how to start understanding the different patterns that are involved in the RxPy and the ReactiveX frameworks?
Yeah, the reactive extensions or the ReactiveX, it can be a bit of what do you call it, a steep learning curve for many people. So, but there are a lot of good documentation out there. Unfortunately, the RxPy is not that good documented, and since it's a hobby project, I should admit that I should be better to write documentation. But the good thing with Rx is that it's sort of a universal language. So if you look at the documentation for one programming language, it will work for all the others. So I would recommend people looking at the ReactiveX homepage, which is at reactivex.io, and also there's much good documentation at Rx Java site. There are a site called Rx Marbles, which people should look at, where you can sort of play interactively with the operators. Channel 9, msdn.com, has tons of videos you can look at.
The Rx Marble site sounds very interesting. I can definitely see how having a visual representation of the data flows and having that be interactive would really help with understanding how the reactive extensions actually operate on the data, because I know that in my experience of trying to use Rx Java on an Android application, it took some doing to really understand what the different operators were and how they all related to each other. But once I actually was able to get some data flows cobbled together, it greatly simplified the overall program, and I was very happy with the end result. So I definitely look forward to being able to integrate RxPy into some of the projects that I work on. When would you want to use RxPy over the async IO event loop or background worker like Celery, or is RxPy particularly best suited for background tasks?
If you look at the Celery, which is a distributed task queue, it's quite different from Rx, which is an event processing library. So I don't think that you should use one or the other, but it could be good to use them together. So that you could use Celery as your sort of platform, and then use Rx within the task functions to do the processing. So you could use Rx to transform the messages, do some computation, and send messages to other tasks. Much more advanced use of Rx would actually be to generate an Rx query and then transform it into an expression tree, or an AST as we call it in Python. And then we could sort of delegate parts of the expression tree out to different tasks in a Celery application. It's a bit more advanced, so I'm not sure if it's clear or not what I tried to tell.
No, that definitely sounds like a very powerful combination, being able to, as it were, compile the data stream and then be able to execute different pieces of that flow on different workers, so that you don't have so that the overall process can be done maybe partly in parallel. That sounds like it would be a very interesting use of RxPy, and particularly the Python AST. And as we were talking, one thing that I was curious about is if there are any particular facilities in RxPy or any associated libraries that facilitate testing of programs that use the RxPy library, and being able to maybe hook into the event streams to provide assertions as the data flows through.
Yeah, we have some tools in the testing module that can be used to look into the data stream. And there's also what is called a virtual scheduler that you could use to process events in virtual time. So you can replay a sort of a huge log file or some event table that you have, And if you have timestamps on that, Rx will process it as it would be done in real life. But the events would replay in like milliseconds.
So what in particular about Python lends itself to the ReactiveX pattern, and what features of the language does RxPy leverage in particular in its implementation?
The thing that when I started writing RxPy, I basically ported most of the RxJS code, and that was basically it was quite easy. You could do it line by line, and the thing that you use in Python is what's called higher order functions. So you need to be able to have functions that you can pass around as parameters to other functions, and you also need to have functions that returns functions. Without that, it would be quite harder to implement RxPy. And you need to be able to define functions within functions. And that is supported by Python, and the only problem is that in Python 3 you have to declare this. If you want to reference a variable from an outer scope, you have to declare it as non-local. And that keyword is not available in Python 2. So it's since RxPy runs on both Python 2 and 3, we couldn't use that. So we had to do a trick by wrapping the variables in an array, because you can read parameters from an outer scope, but you cannot change it. But with a list, I mean not the array, you can read the array and you can change the contents. So you sort of cheat the system a little bit. The other problem is that Rx has like 100 or RxPy has 140 methods on a single class.
Wow.
And this is quite challenging in Python, because you can only have one class in a single file. And if you wanted to have 140 methods in that class, it would look quite ugly. So you could say that the design is not that good, but in C# you have extension methods. So it becomes much cleaner, because you can have one file for every extension method. So I had to implement a way to sort of create extension methods in Python, so you could sort of patch in method into the class.
So at runtime, you sort of monkey patch a method definition and attach it to the class definition before, as it's loading.
Yes. So now that we have so many methods, I'm starting to think that I should probably load on demand or something. So because it can take some time to stitch in all the methods.
So are there any ways in which the Python implementation of the Reactive Extensions framework differs from those of other languages?
Yeah, there are not that many differences, but RxPy tries to follow PEP 8. So all the methods will have be lowercase with separated by underscores. The one more thing is that when calling methods, you should name your parameters, or arguments as we call it in Python. And this is because in Rx there are several methods that have overloads. So the same method can take different kinds of parameters. And in Python we don't support overloaded methods. So I need to sort of call them with all the possible arguments and then detect what the user wanted to do. We have some methods will be like method with X or method with X and Y, etc. And that can also be, I don't like that pattern, but I still have operated like a window. I have window with time, window with count, window with time or count. So I'm hoping to clean that up, but I'm not sure how to do it in a good way in Python.
I think I came across recently a Python library that actually adds the ability to do method overloading, so that might be something to look into.
Yeah, okay.
I'll see if I can find the link to it again, and I'll add it to the show notes and send it to you.
Thank you.
So the project description references the use of link for querying the various data streams that RxPy enables consumption of. I had always heard of link in the context of traditional database queries. What makes link a good choice for stream processing?
Yeah, link, which is the language integrated query that comes from .NET, used in C# and perhaps in Visual Basic, I'm not sure. That can be written as what is called a query comprehension syntax and also a fluent syntax. So you can have like from X in entries where x.value equals 10, then you can select x.name. And this is quite similar actually to what we do in Python with the generator syntax. So in generator syntax, we write x.name for X in entries. So this is about querying collections, and observables can be seen as a future collection. So in a normal list, you have the values already there, and you can query over them. In observables, you don't have any values yet, but you can still make a query, and things will happen when the events eventually arrive. So it sounds a little bit scary at first, but if you think about the iterated pattern in Python, you don't have the values there either. You have to go and call next to get the value, and then you can do your filtering or what you do. So in Rx, we don't have the next method, but we have the opposite, which is on next method. So things will process the same way as you do with a normal collection.
That's really interesting. So I presume, though, that when you're processing a regular list of finite size, there are assumptions in play around, the end, like you can say length and things like that, or you can say .count or something. But for a stream, you can't make those assumptions. Does that affect the style of the way you tend to solve problems and write your code?
Not really, actually. Even with the generator, you're never sure if it will terminate or not. It may terminate or it may not terminate, and it's the same with a stream. It might terminate or it might go on forever. And in Rx, we have this callback called onComplete that will signal the end of the stream, which is sort of the same thing as you would have with a stop iteration exception in an iterator.
So I mostly hear about ReactiveX in terms of UI design, but the project description seemed to indicate that it was much more generally useful. What are some of the less common and more interesting problems that RxPy lends itself to solving?
Yeah, you can actually use RxPy for UI design. I came across a project where a person made an MVC application for PyQt using RxPy. But this is probably not the most common. And if you look at RxJS, which is sort of the hottest Rx implementation, it's all about the UI and the user events. But Rx can also be used server-side. And companies like Netflix uses RxJava client-side, and they sort of expose their API using observables. So you can observe server-side streams. And I think also Couchbase exposes API using observables. And Microsoft actually uses Rx for submitting queries to Cortana. So whenever you ask Cortana for something, if you say to Cortana, remind me if the stock price for MSFT increases with $1, then the client will compose an Rx query. It will generate an expression tree or an AST tree of that. It will be serialized to JSON, and it will be submitted to the Cortana data center. And the data center will compile that AST tree again and activate that query in the data center. And then you will get a notification whenever an event triggers.
That's really interesting. it's a great real world example too, using Cortana. That's definitely something that anybody can understand.
So, in the overall Reactive Extensions framework, what elements have you found to be the most useful, and also which of them have you found to be the hardest to understand in terms of observables or some of the map or flat map functions?
Yeah, as I said earlier, that it can be quite a steep learning curve, and the easiest operators like select and where, which we call filter and map, they are quite easy to understand. But if you go to operators like select many, which takes an item and returns an observable of an item. No, it takes an observable and a function which takes an item and an observable. If you take select many, that takes a function that takes an item and returns an observable of an item, and then returns an observable of an item, then it becomes quite complicated. And especially if you're working with observable streams. So if you're using the window operator will produce observables, which you can then flatten with a select many operator. Then it can be quite tricky to understand. It takes some time and you have to work with it. I didn't understand it myself in the beginning, and that was the reason why I started implementing this library in Python. So I was actually using it in .NET, and I couldn't understand things. So the best way is to implement it yourself.
That's a very good and very interesting motivation, particularly for something as conceptually complex as the Reactive Extensions framework. So we all appreciate your effort on that front.
Thanks.
So are there any questions that we haven't asked you that you think that we should have, like things that we didn't cover that you think our listeners would find helpful, or areas that you would like help with on RxPy that people can pitch in?
Yeah, there's always the sort of need to stay current with what's happening out in the Rx world. Rx Java is moving pretty fast, and I'm sort of having problems with keeping up with all the new operators, and there's sort of a new operator every week, I think. And it would be nice if people wanted to submit pull requests, and I have already received many pull requests for new operators and for schedulers and example code, which is really good, and I think I've actually approved every pull request ever submitted. So if anybody wants to help out, I can promise that the code will be included.
That's great. At this point, why don't we move on to the picks? Like we mentioned previously, this is where we mention things that we find interesting and we think our listeners might find interesting. Tobias, why don't you take it away?
All right, so my first pick this week is a project called ICDiff, which is a diffing library written in Python that is used on the command line and just gives you a really nice output. So rather than a lot of diff programs that have all of the diffs in line vertically, this one actually splits them out horizontally, somewhat similar to what you can get on GitHub. So it's very useful for using in conjunction with Git on the command line when you're trying to diff the changes in your source files, or even just using it as a regular diffing tool between two files outside of Git. So that's one that I've been using for a little while. My next pick is a new game that I picked up recently called Timeline, and it's a card game that has some images and a short description of a certain, could be an invention or an event in history, and on the other side it has that same information plus the year that thing happened. So it might be the invention of the theory of relativity, and then another card might be the invention of stone tools. And what you have to do is you can play with between 2 and 8 players, and everybody gets a stack of cards in front of them, and you have to try and place your cards at the appropriate spot in the timeline. So as you add more cards, it gets harder and harder to get it correct because you have to make sure you place it between the right years and events. And so it's just a really interesting way of learning a little bit more about when things happened and, some new things that you may not have known about having happened before. And each game has a different theme. So there's one for inventions, there's one for world history, one for American history, movies and cinema. And so you can actually mix the different games together to make it even more interesting and complicated. So I've been enjoying playing that recently. And my last pick is going to be the digital art created by Griot, who was our guest on the Avenia episode. And I started looking at the artwork that he has posted on DeviantArt, and it's all just incredible. So I definitely recommend that everybody take a look at that and just marvel at how talented he is. And with that, I will pass it to you, Chris.
My first pick is an Emacs mode called RxPy. I had previously been using and liking Anaconda mode on Tobias's recommendation for writing Python, but RxPy just makes it's just a much smoother process. It has a really great installation and configuration tool, which is a big selling point because getting your Python, configuration going for Emacs can be tricky with the auto completion tools and things like that. They're all very twiddly, and RxPy just really makes the whole thing flow very smoothly. Great UI. It has a lot of great features, auto pep8, auto imports, really great sort of runtime syntax checking. It's just a really, really great tool. It has improved my quality of Python coding life significantly.
I recently switched to it under your recommendation, Chris, and I've definitely been enjoying it.
Cool beans, glad to hear. So my next pick is a tool called S-Shuttle. So this thing is great. I mean, yes, and I can hear the hardcore geeks in the audience saying, but you can do this anyway with SSH. And yes, you can, and ton devices, but S-Shuttle just makes it really easy and convenient. What it does is basically it will take your entire networking, all the networking that you're doing on a given machine, and forward it through an SSH tunnel to another box, which is really handy if you're in a very restrictive environment and you need to, get out to some port that's not supported. You can just SSH tunnel your way into the clear if you have a VPS or something, and away you go. It's really very, very easy to use. Works really well. The performance is surprisingly good. I thought that there would be a significant lag from, encrypting everything over an SSH tunnel, but really, it's barely even noticeable that you're using this tool. So I've been very impressed and would highly recommend it. And my last pick is a beer. It's Chimay Grand Reserve, and I'm sure I'm not pronouncing that right because there's an accent aigu there. But in any case, it's really good. I'd had Chimay any number of times throughout the years, and it's tasty. But this is really, really something special. Even the nose from the foam of this stuff is really smells great and tastes delicious. It's just a really, really great light, Belgian on the lighter side beer. And that's all I have. Dag, what kind of picks do you have for us?
Yeah, I recently came over this Python library called ASTOR, which is for traversing and modifying abstract syntax trees. And that is something I've actually started using in RxPy recently in a sort of private branch. Because I'm trying to implement what's called a kubeservable, which is sort of the data version of an observable. So it's an observable of an expression tree, and then you have code as data, and you need to dump this and see if it makes sense of things. So this library made things a lot easier for me when doing this. I also came across a really exciting book when I visited Redmond and Bellevue recently. And that was a book by a woman called Eugenia Cheng, which is called How to Bake Pie. And it's sort of related to food, but it's actually a book about the mathematics of mathematics. And it sounds scary, but it's sort of, she tries to describe the mathematics behind lambda calculus and functional programming. And this is what's called the category theory, which is quite a scary topic. And I've tried to read several books about this, and I sort of had to give up on page 5 on all of them. But this book looks really nice and easy to read. So I hope to finally I can start to understand this topic, because there seems to be a strange connection between what's called pull and push collections and sync versus async, code versus data. And it's all sort of tied up to this strange mathematics. And I sort of hope to start learning about this.
Yeah, I was just about to say, I'm looking at the Amazon page for the book, and first of all, it's rated 4.5 stars, which is something, and it looks really great. Thank you. I'm definitely going to get a copy of that.
Okay, that's was all I had.
Excellent. So for our listeners who want to keep in touch with you and follow what you're up to, both in your professional life and in your work on RxPy, what would be the best way for them to do that?
Yeah, on RxPy, go to the GitHub page and you can submit pull requests and I'm not sure if my email address is out there, but you can find me on Twitter, D Brattli. Should probably try to spell that, DBRATTLI. Or if you hashtag something with ReactiveX, I will see it.
Excellent. Well, we really appreciate you taking the time out of your day to join us and talk about RxPy, and I'm sure our listeners will enjoy learning more about it. So, again, we appreciate that, and I hope you enjoy the rest of your day.
Yeah, thank you. RxPy has just been a hobby project for me, and it's really exciting if more people start using it. So I hope so. Thank you.